And now this problem is what, based on the longitudinal dynamic stability. So the question is it, the roots of characteristics equation, roots of characteristics, roots of characteristic equation equation for the longitudinal for the longitudinal dynamic dynamics of dynamics of certain aircraft are. So here they are giving the roots directly, and this problem was asked in Gate Aerospace. I think it was asked in 2009. You can check the question paper, you will get it. Okay. And at that time they were asking the linked question, means that one problem they will give, and from there two questions they will ask. So 2 plus 2, it's for 4 marks. This problem is what, for the 4 marks. In one problem will be statement will be given there, and two questions will be asked separately. Okay, so if you have corrected both, then you will get 4 marks directly. And just see the simple question we have, just like previous we had solved the problem, the similar problem we have here also. Okay, so they said the roots they have given, and what are the roots, I'm just writing here. So this is nothing but lambda 1, it is given minus 0.02 plus 0.2 I. Okay, I had written imaginary I first, and then value I had written later. I was like following this way: 0.02 plus I 0.2. So don't get confused, meaning is what same. Okay, another root lambda 2, separately they have given all the roots, minus 0.02 minus 0.2 I, means simple, minus 0.02 minus imaginary 0.2. Okay, this is the second root. Third root they have given lambda 3, they had given minus 2.5 plus 2.6 I, means 2.5 plus imaginary 2.6, this minus value. Another last one more roots they have given. Okay, it is minus 2.5 minus 2.6 I, means minus 2.5 minus I 2.6. Okay, these 4 roots they have given. Okay, now and they also saying it's a basic only, where this is the problem where I value is given, and if you know the complex number, so you know very well imaginary I value is what, root of minus 1. That is basic, you know that. Okay, now just listen the question. What is the question? This is the statement, one statement, and 2 plus 2 means two question will be asked to you, and each question containing 2 marks. So first problem what they are asking, just listen carefully. They are saying the pair of, listen carefully, the pair of eigenvalues, just for your knowledge, eigenvalues means they are talking about the roots. Okay, eigenvalues that represents the that represents cuboid mode. This is question number 1. Option you have to write. Option you have to write lambda 1 and lambda 3. Option B lambda 2 and lambda 4. Option C lambda 3 and lambda 4. Option D is nothing but lambda 1 and lambda 2. This is the question number 1. Okay, this is question number. Hello, हाँ it is. हाँ, अरे यार, ठीक है, 1 घंटे हो गया होगा. Another problem is number 2. Here it is nothing but the short period. The question is number 2. Question is the short period damped frequency. Okay. Option they have given to us. What are the options? Damped frequency they ask. So 2.6 radian per second. B is nothing but 0.2 radian per second. C option is 2.5 radian per second, and D option is nothing but 0.02 radian per second. Remember, I told you this was GATE 2009, GATE Aerospace 2009 question, and 2 plus 2 means problem 1 was asked for 2 marks. Here, this was for 2 marks, and this was also for 2 marks. Okay, linked question. Now, so we'll go for the solution. See the pair of eigen values or roots they have given that represents the figured mode. Okay, so which are the two pairs? Which were the pair of the roots or pair of the eigen values? Means pair means two roots they are talking. That two roots are representing figured modes. Okay, so how you would know which one is the phugoid mode, which one is a short period oscillation? So I told you phugoid means what? Long period oscillation. Long period oscillation means a
Sir, lambda 1, lambda 2.
long period oscillation means natural frequency should be less or damping ratio should be less. Then only it will have a long period oscillation. So in which case we have a damping ratio is less or natural frequency is less. You see, so damping ratio or natural frequency you will check with the real roots. So this is the real part. Okay, actually this is the combination lambda 3 lambda 4, like plus minus. See, it is same only, the plus minus difference. So this one you can say as per our study it was lambda 3 4, and this one was lambda 1 2. If you check this 2, so the real part is what? Here it is very small, and real part was the damping ratio or natural frequency product, if you remember. So if natural frequency is less, okay, if natural frequency is less, it means it have a long period oscillation. Or damping ratio is less, it means it have a long period oscillation. So long period phugoid is what? Phugoid means long period oscillation. So which one have a less natural frequency, real parts, that will be the long period oscillation. So 1 and 2. So your answer is 1 and 2. This is the first one. Sorry, D is correct answer. Okay. Here, see, first one is lambda 1, lambda 3, lambda 3, lambda 4, lambda 2. So what is your correct answer? Lambda 1 and lambda. Second, they are asking short period damped frequency. So short period damped frequency means first you have to check that roots for the short period oscillation. So what are the roots for the short period oscillation? If you check short period oscillation, roots is nothing but lambda 3 and lambda 4. So for this lambda 3 and lambda 4, if you check, it is nothing but I can write this second one. So lambda 3, lambda 4, if you write this root, so this is for the short period oscillation, and this is nothing but minus of 2.5 plus minus 2.6 I. Yeah? So minus of 2.5, minus of 2.5, and then minus I of 2.6. This is what the short period oscillation. Okay, roots I have written. All right. Now, if you want to calculate the value of uh, damping frequency or damped frequency, they are saying in radian per second. So, how to solve this? It's very simple. You have to compare. Now, this is the solution. This is the solution for this problem. Lambda is nothing but minus of xi omega n plus minus root of 1 minus xi square omega n I. And I told you 1 minus chi square root omega n. This is nothing but WD, which is nothing but damping frequency. So damping frequency means they are asking WD only. So for WD, you should know what is the chi and what is the omega n. What is the chi and omega n? So you have to solve this. Okay, you have to solve this, and you just compare this two, and you just try to find out what are the value. So what you will do for this, simple steps you have to follow. The simple steps are minus here. Just compare this minus xi omega n is nothing but minus 2.5. This is equation number 1. And the another is nothing but omega n root of 1 minus chi square omega n is equal to, it is nothing but 2.6. This is equation number 2. You have to solve this. Okay. So now, I mean, you have to calculate the value of omega n and xi separately, and then you can find out this value. One thing. Second thing, my means 1 minus xi square omega n, you separately you calculate and write WD formula. But if you know that this 1 minus xi square omega n itself is omega d, huh? Then directly you can say this is nothing but, just say this part is the value of which is real, you can say r, and this is imaginary, which is q, and this imaginary q is nothing but omega d also. So what is that value? It's a 2.6 radian per second, because this whole value 1 minus chi square in root omega n is nothing but omega d. So only omega d they are asking. So you have to just compare. So what is the value of omega d? It's a simple 2.6. Check where is the 2.6 option. 2.6 radian means option is correct. So here I took time because I just wanted
Option
to
1, sir.
explain. I wanted to explain. Otherwise, if you know, then 4 marks in your pocket, and it's very simple. All right.